So what we have here on this graph is a visual representation of a function, and it's the function y is equal to g of x. Now, this g of x notation, this is what we call function notation. And it can be intimidating sometimes, but it really doesn't need to be. So what this notation is telling you is that we have a function and its name is g. And this means that the function g takes the input of x, it inputs it into the function, and then g produces an output that we call y. So x is the input, and it's an input into the function g, and then g applies some rule to x and outputs a value y. So actually our ordered pairs here on this graph are giving us pairs of inputs and outputs of the function g. So that means we can do some function evaluations. We can find some values of our function here. What if we wanted to know the value of g of 6? So if we take an input, an x value of 6, and we input it into our function g, what's the output going to be? Well, I see that on the x-axis, a value of 6, my function value is all the way up here, and I look for the y value at that point. And the y value there is 8. So that means that the output must be 8. So that means when we input 6 into our function g, we get an output of 8. So that's our x and our y coordinates for that point, 6, 8. What if we want to evaluate g of 0? Well, we go, okay, well, let's look at our x-axis and find our value of 0. And here's our function value up here. And I notice that the y-coordinate of that point is 4. So when we input a value of 0, we get an output of a value of 4. Again, that's our x and y coordinates of that point, 0, 4. Now, what if we want to evaluate, let's say, how about g of negative 2? So we look again on our graph. We say, okay, here's negative 2 on our x-axis, and here's our function value. And the y-coordinate there is 5. So g of negative 2 is 5. Now let's evaluate g of 5. So let's find 5, our input of 5, that's an x value. And here's our 5, there's our function value, and the y-coordinate there is 5. And so I'm noticing that g of negative 2 equals 5, but g of 5 also equals 5. That's okay. It's okay to have a function that takes two different inputs. That's important. It's two different inputs, and they're going to output the same value. Now, here's what's not okay. Let's say maybe we had a point. Let's add a point to this graph. What if we added a point right here? Okay, so now let's come down and let's try to evaluate g of 3. And let's say, okay, what does that function value equal? If we input 3 into our function g, what is the output going to be now? So I'm looking and I go, okay, well, here's 3 on my x-axis, and I have 2 points at that value. I have 2 function values here. I could have a value of 1, or it could be 3. I don't know which one it is. So that is why this is not a legal move when we're talking about functions. We cannot have an input that could have a possibility of producing 2 different outputs. That's not legal. So when you have a function, it's really important that the rule is for every input, it can have exactly 1 output. So we can't add that point there because then there's confusion. For our function, we don't know what the output would be for g of 3. So this makes it no longer a function if that point was added there.